Good morning, everyone.
Good morning.
Share my screen. And can everyone see my screen?
Yes.
Yeah.
Perfect. Okay. So have a number of things on the agenda for today. The first of which is we're going to finish up a couple of things with CSS that some of you pointed out after lecture last time that I wanted to show to the rest of you. And then we're going to move into PHP and scripting languages. And in fact, the rest of the course essentially is devoted to scripting languages, and particularly scripting languages that are associated with web programming. So couple of things that I neglected to mention. First is that you can just as easily use a flex box to center something as you can a grid box. So last time with my solution, my flex solution, I was using a center I was doing this to center the instructions in the nav block and the main block, but that wasn't necessary because just like with grid, I can turn those two blocks into flex blocks. Let's see. There we go. So here with nav, I simply made it itself a display using flex, and then I justified the content using center, and I was able to center it. And if I had said then align items, I could have gotten it to center it vertically as well. So not only can you pull that trick of centering with grids, you can also pull the trick of centering things with flex, just having the block itself be laid out using the flex layout. So wanted to show you that. And then another nice thing is if you bring up the web console, so on Firefox, I can do that by going to Tools and Web Developer, and I can bring up the browser console. And well, not quite what I wanted. There we go, Web Developer Tools, or on the Mac, I can just hit the function and F12 buttons. I'm not sure what it is on Windows, but you can do something similar, and you can do something similar in Chrome. And it will bring up, let's see if I can make this just a little bit bigger. Looks like, unfortunately, no. So down here, you see Inspector and Style Editor. So in the Inspector, you can go in and you can look at the actual HTML that you have created. And over here, you see the style information for it. So, and as I mouse over things like the body, you see up there, it highlighted the area for the body. When I go to the header, it highlights the area for the header, and it says that its dimensions are 1276 by 61. When I go to the div for the container, it highlights the div for the container, and you can see there's a little black box up there indicating it's a flex container and what its dimensions are. And then I can use these little arrows. I know they're hard to see, but that will give me more stuff. So when I go into nav, it now will highlight nav, the dot dot, and you can see it now highlights sections. So that's a nice way without having to draw borders to actually see how everything is being positioned. And then you can interactively modify the style sheet. So here, a line item, I could say flex start, and it moves it up to the top. So it's interpreted, and so you can actually play around with the style sheets. So you could also just go to Style Editor and play around with it there, or just play with it as you saw me doing. So I want to see what happens if I give more padding. Whoops. And you can see it floated over a little bit. So look up here, and while I do my edit, and you can see how it floated it over to indicate more padding. So that's a nice, these tools, these web developer tools are a nice way of being able to interactively play with your design without having to constantly go into an editor and then redisplay the web page. Instead, you can just play with it there. And again, on a Mac, the way I am able to get to it is in Firefox. Well, on a Mac, you should be able to get to those web developer tools. Using the function and F12 keys, or by going in Mozilla, which is Firefox, you can go to Tools, Web Developer. And something similar exists in Chrome, so very helpful. Any questions about that?
Can I add something?
Yes, absolutely.
There's actually a way when you're working with files, local files, instead of on a separate web server, you can have the dev tools sync your changes with your local files automatically, which is useful in certain situations.
Okay, how can you do that?
I think it's that plus button that you see above the
Right there?
thing. Yeah.
Create and
maybe
append
not.
a new style sheet. Yes, you're right. So I'm not
It
going
might
to
be
do
something
it.
like that, but there's definitely ways. I don't know if it works for CSS that is inline in an HTML file. It might work, but either
Okay.
way, there's people can look into it. There's ways for that to happen.
Thinking it. Okay, thank you. So in case y'all didn't hear it, the comment was there are ways to actually on your local machine, which is what I am here, you can actually get the changes you made actually written back to the style sheet. One possible way is this plus button over here, but you need to look it up. And that did remind me that my solution used a inline style sheet that was embedded in the HTML, but that's not the way I want you to submit your web project because it's not the recommended way to do it. The recommended way is you put the style sheets in a separate .css file. So what you're actually supposed to do is take these styles and put them off into a separate style sheet like foo.css. And the style sheets by convention are named CSS, and then import the style sheet. And of course, I need to look that up because I never remember what the way is, what the specific wording is. So for an external, it's link this. So we will put it in here. So you still have you don't need a style either. You just in the head statement, you have link, then this rel says it's a style sheet, href, in this case would be foo.css. And when I display it, displays just like I want it. So this is what I want you to do for the web project. I actually want you to put the styles in a separate style sheet, and then you just, the way you reference them is with this link tag in the head section of the HTML file, and indicate with this rel attribute that's a style sheet, and it will bring it in. And the web project is clear that it wants separate style sheets for each of the three main pages: a login style sheet, one for the page where you enter the ABIT information, and a third style sheet for the password page.
I have a
Okay.
question about that.
Pardon?
I have a question about that.
Yes.
In that style sheet, is it okay if we use the CSS import to like share styles between pages?
Yeah, that's fine. Absolutely.
Okay.
So,
Thank you.
yeah, no need to have to duplicate things multiple times. I'm assuming that your issue is with the nav, partly with the nav bar.
Right.
Not.
And typography and anything
Yep,
else.
gotcha. There's a trick actually with that nav bar that you can also import HTML so that you don't have to duplicate the nav bar. But rather than trying to do that on the fly, that's actually a good thing to show you all so that you don't have to essentially copy and paste all the nav bar code twice, one for the abit.html file and one for the password.html file. There's ways you can import that as well. Okay, other questions or concerns? Okay, in that case, let's move on to PHP. And did I just last year, and for people who took 365 last year, was Python or any scripting language covered in 365 last year? Anyone? Someone took it. I know someone took 365 last year. Not this semester. This semester, we're talking about Python. Who took it from Dr. Henley?
I think when I took it with Dr. Henley, I think it was either a year ago from this semester or the fall semester a year ago, but we went over mostly functional programming like Haskell, Lisp, and then
Okay,
I think
gotcha.
we ended this semester.
Racket. We had Racket too.
Okay.
Yeah.
Racket, though, is, if I'm not mistaken, a scheme-based.
I think Racket is a derivative of Lisp, I believe.
Yeah, it's a Lisp derivative. Okay. Okay. That means I need to do this slide very quickly because some of you are taking 365 from me this semester, but many of you aren't. So let me.
I will say, in Henley's 340, we went over Python a fair bit.
Okay.
Or at least last semester's 340 did.
Okay. So I guess, okay, very good. I guess let me just, there's something I do want to quickly show. There we go. We'll just take a moment. And for those of you who take my 365, they've already seen this, but let's get just everyone on the same page. So basically, with scripting languages, the goal is to accomplish specific tasks quickly without a concern for machine efficiency. So the emphasis is on programmer efficiency. And the idea is if you are writing something that is going to take a millisecond to execute, why spend 30 minutes trying to get its execution down to, say, half a millisecond, when you might be able to write it with a scripting language in 2 or 3 minutes, but it'll take 1 or 2 milliseconds. The human eye will never notice the difference, but it will be much faster obviously, to write it in 2 or 3 minutes versus 30 minutes. Now, if instead you're writing a piece of code that's a huge simulation of a planetary system and it's going to run for days, then machine efficiency is very important. Programmer efficiency, less important, and we're willing to devote hours of programmer time to try to make the program as efficient as possible. Or if we are distributing a program and it's going to be widely used millions of times, and maybe each time it runs, it takes 2 or 3 seconds, again, we're willing to sacrifice programmer efficiency to make it efficient because of how many times it's going to be used and how much machine time in the aggregate it will take. But as I said, if either the task normally is, no matter how efficiently or inefficiently I code it, it's only going to take a millisecond or 2, or I am not going to use it more than a couple times, then machine efficiency may not be important. For example, if I'm writing something to compute grades for a course, I'm only going to use it once. I don't care if it takes, say, 30 seconds to run or 2 minutes to run. But let's say to get it to run in 30 seconds, I have to program for an hour. And to get it to run in 2 minutes with a scripting language, it takes me 10 minutes. Well, that means 10 minutes plus 2 minutes is 12 minutes for the scripting language versus an hour plus 30 seconds for the compiled language. Obviously, the scripting language wins. So there are many times when programmer efficiency, when you add up programmer efficiency and machine efficiency, the emphasis needs to be on programmer efficiency and reducing the amount of time required to write the program. So that is what scripting languages seek to do. And they seek to do it through economy of expression. And the way they do that is through a number of techniques, some of which you may or may not like. A lack of variable declaration. So you don't have to declare a variable or even its type. In fact, the type of a variable is determined by what's assigned to it at runtime. So for example, I can start out in PHP and I can, in PHP, your variables are prefixed with a $sign. I can say $A equals 6, and now A is typed dynamically as an integer, but later I might say A equals Brad, and now it's dynamically typed as a string, and later yet I might assign it an array, and now it is typed as an array. So not only do you not have to declare things, but you also don't have to indicate a type. The type can change dynamically. And some people don't like that because it can make it hard to find type errors. It will go ahead, the scripting languages will frequently go ahead and try to convert stuff. Like if you have something like A equals B plus C, and say B is a string and C is an integer, then a compiled language would probably or might give you an error message saying those are incompatible types. But a scripting language might very well go ahead, convert the integer to a string, and then concatenate them. So that can get you some grief, basically, when things don't work the way you want, and they might have been caught by stricter type checking. Scripting languages often give you easy access to system facilities. So Windows, Linux, and Mac often have different commands for accessing system commands. So in Windows, to list the contents of a directory, it's dir. In the Mac and Linux, because Mac is Linux, the command would be ls to list the contents of a directory. So Python and other scripting languages, they give you system independent ways to access those commands. And we're not going to worry a whole lot about that in this course because we're more emphasizing web programming, but system administrators make extensive use of Python and Perl for doing scripting because of the easy access they give to manipulating the system and file system. Then scripting languages also have a big emphasis on string manipulation and being able to easily type check strings, pattern match, and the like. So we will see this later, but just as a taste of it, let's say that we want to require a birth date to have 2 digits. So the way we might do that is like this. The \d means 0 to 9. So we're saying 2 digits for, let's say, the month, and 2 digits for the day, and 4 digits for the year. And now we can easily type check a string. If it doesn't match this pattern, we will give an error message. Now we know that dates may have often just one thing, and we may want to limit it to things after 2000. So we could instead add a question mark here, which means it's optional. The second digit becomes optional. It's 0 or 1. And here we can replace that with 20 \d2. And now the first 2 digits must be 20 followed by 2 arbitrary digits. So there is all kinds of things you can do to make type checking easier with scripting languages by using what are called regular expressions. These are called regular expressions, and we will get to them in a couple days. But they are very handy for manipulating strings, type checking, and the like. And those facilities aren't generally easily provided by high-level languages, or I'm sorry, by compiled languages. Then scripting languages generally have 2 built-in data types, lists and hash tables. The lists may also be called arrays. In fact, generally scripting languages implement lists as arrays. So even though they call them lists, like in Python, they're actually arrays. In PHP, they're straightforward and call them arrays. Hash tables are also built in. You'll often hear them called associative arrays or dictionaries, but they are hash tables. Okay. By contrast, trees are typically not a built-in data type, and that is because it is rather uncommon to actually need to keep data in sorted order in a data structure. The only real reason is for range queries, where you want to be able to say, for example, I want all race results where the runners finish the race between 15 and 17 minutes. So in that case, you do want a tree. But it turns out that most of the find operations and delete operations and insert operations that we do in everyday programming don't require us to keep the data in sorted order. And in that case, hash tables are more efficient than trees. And that's why scripting languages pretty much universally have hash tables built in, but not trees. And when I say built in, what I mean by that is we'll see is that there's actual syntax that supports lists and hash tables. You saw that a moment ago when I used square brackets to assign a list to A. That was built-in notation in PHP for creating arrays. And then finally, scripting languages are interpreted, which makes them typically much slower than compiled languages, but much more flexible. That's why you don't have to have these variable declarations, and you can have flexible dynamic typing, is because they are interpreted, but therefore they're not as fast. Okay, so the two scripting languages we're going to consider in this course are used for web programming, and they are PHP and JavaScript. So PHP is going to be used for programming on the server side. JavaScript will be used for programming on the client side. So PHP.
Dr. VZ,
Yes.
sorry to interrupt real quick. Those notes that you were just describing about scripting languages, is that posted somewhere?
I can post them. I'll post them on Piazza.
Okay, I appreciate that. Thank you.
You're welcome. Other questions before I go on? Okay, so PHP used to be called, when it was first invented, it was called Personal Homepage. And the reason for its invention was that when the World Wide Web first debuted in the early 90s, HTML just had static pages, which is fine for a lot of content, but isn't very good for dynamic content. Like, say, if you want to stream stock quotes or the scores of various games or vote tallies during an election, you want to keep updating them. It's not good for doing any of that kind of dynamic computation where you want to periodically update the web page. And so the developer of PHP said, okay, I would like to do this. And initially he just, it's for his own personal home pages, but very quickly it became popular. And so now PHP stands for PHP Hypertext Processor, which of course is like PHP, and having it as the first actual word of your acronym isn't really a great way of doing an acronym, but that's what it stands for these days. And what happens when you execute a PHP page is it generates HTML. So what happens is the user can start by typing an address into a browser. Say they do this. So they type this into a browser. And what would happen is the browser would go to a directory on the web EECS server for BVZ, find foo.php and execute it. Then, so that goes to the server where it executes. And that produces a web page, which is sent back to the client. And the client displays it. Okay, so that was the big innovation of the PHP language, was the ability to automatically or dynamically create web pages. And the way it did it was it allows you to, let me actually log in. So you can just enter normal HTML stuff. So I'll say, hi, Brad. So that's just normal HTML. And I'll write it out, make sure that I can display it. Yep. So I'll go to here, type in Evander Z, foo.php, and I get hi, Brad. Now, that's not very interesting because I could do that with a HTML files. So what makes PHP so interesting is the ability to add what are called code islands. So here is a PHP code island for, one second. Don't have to. Okay, so create a code island with PHP. So I'm going to say, first of all, I'm going to create an ordered list. So I'm going to, the static part is the ordered list. And then I'm just going to count from 0 to 10. And I'm going to echo out a tag line item and the value of $i+1. Okay. And just to make sure it's running, I'm going to do it first from the command line. It worked, so it should also work here. And as you can see, it generated an ordered list from 1 to 10. Okay. So that's the neat thing about PHP, is the ability to dynamically generate this kind of HTML content. And as you see here, what I did, I actually ran it at the command line and was able to see what the output looked like. So this is the actual HTML that gets sent back to the browser. And it doesn't matter that it's not well formatted in terms of being easy to read by the human eye, because the browser doesn't care, okay? It's able to interpret this output just fine. And that's why I didn't bother putting a new line character here. I could have to have made it look nice and pleasing to the human eye, but it wasn't necessary to get pleasing output for HTML. Okay, and if you want to make this run at UT, you may have noticed that I CD'd into a web home directory. So where you want to put your PHP files is in a web home directory. You'll also notice before I tried to display it, I checked the read permissions because it has to be readable. Doesn't have to be executable, but it does have to be world readable in order to be displayed. And of course, you can put them in subdirectories. So I could move foo.php to say a temp directory, and then I could run it out of my temp directory instead. Still works. You'll notice that here with BVZ, I did not add web home. So it automatically goes to web home. Okay, you don't need to add anything. You don't put web home. In fact, if I put web home here, it wouldn't work because it would then go to web home/web home, and that's no good. Okay, and then the other thing is I like to run my commands using the command line interpreter first so that I can see. Now it's in temp, so let's move it back. I like to often check that my stuff is running, so you can run it at the command line first to see what is going on. Unlike Python, there is no command line interpreter, so you can't do a command line interpreter, but you can at least run a script using the PHP interpreter. Now, if I make a mistake, so I'm going to intentionally introduce a syntax error by omitting a curly brace. So that creates a syntax error. And when I run it, I get a blank screen. And the lab staff here has done that intentionally because it doesn't want hackers to get information that might allow them to break into our system. By giving feedback about what's wrong, it could aid a hacker. So if you make a mistake in your PHP files, it's simply going to give you a blank screen, but it's easy enough to check what's going on. Just again, go to the command line interpreter and it will give you a nice error message. So syntax error, unexpected, curly brace on line 6, which of course isn't the best error message because the error occurred up here where I forgot the opening curly brace, but at least you get some error message. Okay, so this is what made PHP so successful. This very simple idea of these embedded code islands that allow you to intersperse HTML with code. And the variables retain their values across code islands. So now I could have some more stuff like a horizontal rule, H1 by Brad. And now I'm just going to print in boldface the value of the variable. And here I can do it. This is a cute thing. I can just say less than question mark equal in the variable name. And then, so that's shorthand Python, or I'm sorry, PHP. So that just interpolates a variable. So here I should now be 10 because that's what caused it to exit the loop. And there you go, 10 is highlighted. So the point here was that the variables maintain their scope. They stay in scope even after you get out of the code island. They remain in scope for the remainder of the execution of the script or this page. Okay, so the next thing that you got to get used to in dealing with PHP is that we typically do not read or write to the console. So our I/O is different. Okay, input typically comes from forms. And output goes to the browser rather than to the console. So both your reading and your writing is not the way you would expect. So as you noticed already here, all of my echo statements just produced HTML code that was interpreted by the browser. And you normally get form data from the browser, which can be, you need to somehow simulate that. And the way you can do that is this it? I copied something and now I can't access it. Okay, well, I'm going to have to look it up then. Okay, so here it is. There is a command called PHP CGI, and CGI stands for Common Gateway Interface. It's the standard that is used for transmitting data to and from a browser and a server. So when you transmit form data from an HTML page to the server, it's going through something called the Common Gateway Interface. And you don't have to know how it's implemented. It's like the plumbing of the internet. But what it does is it packages up form data into those key value pairs that I in fact showed you with the get method for posting form data with a URL. And that gets encoded and sent over to the server. So the way that we can simulate that is with the php-cgi command. You give it the name of the script you want to execute, and then you give it key value pairs with the key, equal, and then the value in strings. And when you execute that, it will bundle it up into a $_get. So we will quickly do that. Copy it. I'm going to actually say for, so we'll just say name, $name equals $_get email, $, what was it, password, $_get password. We'll print them out. So I'm showing you a different command, print, and we'll say name equals. Now I'm going to show you interpolation in action. So when you put a variable name inside a string like I just did, it interpolates the value. So whatever is contained in $password will be interpolated into this string. So we will run. No input file specified. That's because it's not login.php, it's foo.php. And you can see, wait, what the heck? Why is it not running my file for me? Actually, it is running the file. Oh, I forgot to put this in a code island is the problem. Put this in a PHP code island. Notice I'm not ending it with a tag. Let's actually see if I don't think this works if I actually do it like this. Let's just make sure about that. Yep, it didn't work. Notice it's still echoing it out faithfully. So you got to make sure when you create these code islands, you don't finish the tag there. And here you don't start the tag. In effect, you just end it. Okay, now I got what I wanted. Name equals coyote at UTK, password equals password, which is what these two key value pairs were set to, coyote at UTK and password. So when you're testing your programs, you're generally going to be using this php-cgi command because that will bundle up your input into a $_get array, which is what contains form data. So if you're going to use post, it doesn't work. You have to use get with php-cgi. But once you have your script working, you can always change. You don't have to worry about it. So you have to use get with php-cgi, but it's a good way of simulating the input of form data to a PHP program. Okay, so with that, you've been kind of given a nice introduction to PHP and how to get it to run on our web servers. Again, just emphasize that you need to, whoops, put your PHP scripts in your web home directory. And then it will be automatically displayable. Make sure they are world readable. And this is why I had to make a video of your project and can't just, quote, give you an executable, because there in fact is no way for me to allow you to run the website for this course without your also being able to look at my HTML, CSS files, and PHP files, because I have to make them world readable in order for you to execute them. So while an outside person outside UTK can't look at my PHP files and my CSS files and my, you could. And that's why I had to produce a video of the website. Okay, so questions thus far. So what I'm going to do next is a fairly quick run through of PHP, because it is very similar to C, C++. The syntax, you can already see, like with the for loop, it has a counting loop that looks just like C, right down to the increment operator. So they took much of C and C++ syntax and incorporated it in PHP. So I'm basically interested in what's different because of how similar it is. You'll probably notice that when you went through classes in section 9 of the book, how similar that looked to C++. And we're not really going to worry about classes in this course, but the point is just how similar it is. Okay, so the things that you do have to remember: variable names start with a $sign. So remember that when you create variables, you must prefix them with $signs. You noticed how when I created the code islands, they need to start with this tag, but not end with a greater than sign. And when you want to end the code island, it's a question mark greater than. And again, you don't start that with a less than sign.
Dr. VZ?
Yes.
Oh, sorry, I said something a little, I think I had the mute on. Just so I'm just trying to get clear what we're doing with the, as we move on with the web project. Like right now I'm doing local stuff, HTML, CSS, to try to get the look of the pages right for the part 2.
Yes.
But when we move on to part 3, we're going to take all that HTML, move to web home and start making .php files from that, and then injecting the code, the PHP code as we need to. Is that kind of the flow there? And then we'll be connecting to the
actually,
database.
the way the web project is set up, you won't have to integrate your HTML with your PHP until the final web project. So the third web project is just having you convert your SQL queries from the first project into PHP SQL, and doesn't have any interaction yet with the browser. Still, so actually it turns out you still could run everything locally, even for Web Project 3. It's only in Web Project 4, when you're tying it all together, that you'll have to move to Web Home. So for the foreseeable future, actually, you still could do all your development locally. Although that's not true. When you get to Web Project 3, the databases are actually on the Hydra machine. So you'll at the very least have to run your scripts from the Hydra machines.
Well, I mean, I'm able to access the database using like bash scripting. So I've been doing everything local without having to log on.
Yeah, it's just
But,
be aware the TA is going to, for basically the rule of thumb is it's got to work on the Hydra machine. So if the TA decides that they're going to take your web project too, and they're going to run it in their web home directory, it better work.
right.
But I can pretty much guarantee you that if it works locally, it will work from the TA's web home directory.
Okay. Okay. Yeah. If I have any more questions about this, I'll
Yeah,
speak
so
up
I would
again,
say
but I
pretty
think I
much
get what you're saying.
for, you can develop locally for the next couple assignments. It's only for the last one that you're going to have to really make use of the web home directory. Other questions before I continue? Okay. So you've already seen strings and string interpolation where you can put a variable inside of a string. You can also actually do that with dictionaries. So I believe I could have actually said, we'll check this. And it didn't like that. Try this, see if it likes this. Okay, still didn't quite like that. Huh. Okay, so I think you're supposed to be able to interpolate using dictionaries, but I have to figure out how to do it. At any rate, you can also use the curly braces like this, because let's say that I didn't want there. Normally, it knows where a string ends when there's a white space character like \n. But if you wanted something else right after it that was not a white space character, like say that, then you could put the thing to be interpolated in curly braces. So it would know, the PHP interpreter would know where it ended. And actually it looks like my problem is right here. Password is password. And let's go back in here and see now if I can't do that $get again. Yep, it worked. Okay. So you can interpolate using a dictionary. You just have to put it in curly braces so that it knows where the interpolation is beginning and ending. Now, that only works for double quotes. If I move to single quotes, then interpolation is off. And I'll have to put actually, interpolation is completely off. So let me not do this one because it's too complicated. Let me change this one to single quotes. And you'll notice that interpolation is off. And it actually printed name equals $name \n. It even ignored the \n. It just literally printed out the string. So if you just want things done literally, you use single quotes. But if you want interpolation and \n's to be interpreted in the normal way, you have to use double quotes. Okay, and there's a whole set of useful functions for dealing with strings. A big one is that you often want to trim characters off the beginning or the end. So when you read stuff, which again, we may not do a lot of reading of things, but you often, when you read something, say from a file, you're going to get new line characters at the end. So you might get A equals, hi Brad, and you read a line, you get that new line character. So a useful function is strip, or trim rather. So you can say trim $A. Of course, I left off the $, and that will trim leading and trailing white space, which is \S, \T for tab, \N for new line, \F for form feed, and \R for the return character. So all of those are considered white space and will be trimmed when you use it. There is also L trim and R trim, which will trim the left or right. So L trim will trim leading white space, R trim will trim trailing white space. And it doesn't do in-place editing, so you actually have to assign the result back like that. So if you don't do it, the original A is left unchanged. What you get back is a copy. Okay, another nice thing is the ability to split a line based on characters. So for example, there we had $A, and we might want to break it up into its its component words. And the way you can do that, you could say $words equals explode. And I'm going to explode it on white space, and the name of the string. Now you're going to see me use print R. So print R is a handy way for printing out an array. So print R prints the contents of an array. Not print. If you try to do, I'll show you, if you just say print $words, that's not going to do what you want. Print R will do the trick. So what I'm doing, I'm exploding A based on white space. So I should get hi and Brad. And it didn't like that. Let's see, why not? That's because I didn't use a comment. Still didn't like it. $words. $23. It's supposed to work.
I think you're missing a semicolon.
Am I? Oh, here. Thank you. Thank you so much. Missing up there. Love having. Okay. So you'll see that it indeed exploded it, and that's the output of print R. This is the output of the print statement. So the print statement just prints the type of the object when it's a complex object, but print R prints the entire array. So knowing about print R is kind of handy because it is a convenient way to, again, quickly print the contents of an array in a formatted way. You'll notice hashtag is one of the types of comments you can have, but of course, C style comments are fine. I'm sorry, C++ style and C style comments, all fine as well. So 3 types of comment characters. Okay. We will show you, unfortunately, with explode, there's a little bit of an issue. It doesn't collapse white space. So I'm going to add a bunch of white space characters there. You'll notice all those extra empty spaces in there. And that is because it thinks, when it sees that white space is a delimiter. So when it sees a bunch of every time it sees the white space, it's saying, okay, that's a word, that's an empty string. That's a word, that's an empty string. That's a word, that's an empty string. Not exactly what you want. So we will show you later how there are other ways that you can use regular expressions to collapse that white space, but we won't worry about it just yet. Okay, so the important, I guess, type values for our constants for bools. They are true and false, not case sensitive. So you can use all uppercase, and null, again, not case sensitive, is what you use for undefined variables or to, if you're trying to use a null reference, you use null. Okay, conditionals, they are the same as in C++. Let me actually just quickly go to my notes. So my CLIS version, what I'm going through now is my CLIS versions notes, and they're very helpful for just being a very succinct reference for PHP. So if you don't necessarily have to do a lot of Googling. So a couple things with if then else. You're allowed, when you have an else if, to put no space between the else and the if. Remember programmer efficiency, it saves you one keystroke. Typically you use the C++ and or for your Boolean logic, but and or, interestingly enough, are also defined with different precedents. Most programmers use the C style and or, but I don't care which one you use. Also, most scripting languages, including PHP, extend the meaning of switch so it works with strings. So for example, I can say something like $A equals word. And now I can say switch on $A. And I can have different case statements like buy, does something, break. So that's kind of nice. Make sure you put break statements at the end of your code so that, or each case statement, or otherwise it will just continue into the next case statement. But it is definitely nice not to have to write a sequence of if else's for when you're checking whether a variable matches some set of words. You can just use a case statement like this instead, which is very handy. Okay, functions get introduced with the function keyword, and all variables are local. So if you start using a variable, it will be defined locally. So let me start a smaller PHP file. Let's say I have a variable value and a function. And I call that function. And now I print value. And you're going to see value is unchanged because it's going to create a local version of value here. So Value stayed at 10. It did not change to 20. If I wanted to use the global version, I would have to say global $value. Now it will use the global value version of value. Did I do wrong? Put that in there. And value changed to 20. So everything goes into the local namespace unless you declare it as global. And by default, things are passed by value. So another thing I could try, setting value equals 20. And this isn't going to work because things are passed by value. So when I come out, it's still 10. But just like in C++, I can put a ampersand in front of it. And now it's passed by reference. And ta-da, it's 20. So using an ampersand, I can pass arguments by reference. Okay, if I want to include other files, the way I do it is with the include or require statement. Generally, require is better because include will, well, let's just show you. So this one doesn't exist. And whoops, unexpected value. Okay, I got a warning, include.h failed to open, but it still ran the file, okay, and executed it. If I change that to require, that should change it into an error. You'll notice it didn't execute. It went from a PHP warning to a PHP fatal error. So I would probably suggest you use require rather than include, and then require, you should be able to say require once. Make sure that works. Yep. So that will ensure it only loads one time. So if, for example, you had tax.php included within tax.php, you'd rather not have it load twice. So include once and require once will ensure that something gets included only once. Okay, you've seen there's 3 different print commands in PHP. They are echo, which will print multiple arguments with a space between them. Print, which will only print one argument, which is kind of unfortunate, but you can always concatenate using the dot operator if you want. But it's not quite as easy as echo. And then you have printf, which pretty much operates just like it does in C, but you rarely need to actually print formatted output because CSS is what you're using to format HTML content. So unless you're trying to format something in a string, like get something to center in a string, which again, there's just not a lot of use, it turns out, for printf, but it is there. Okay, file IO is very much like C, but so you can open something and get a file handle, and then you can read from it using fgetS in the file handle. And if you want to read from standard in, there is a predefined file handle called standard in. There is no getS because PHP was meant to read from a browser. It wasn't meant to read originally from the console. So if you want to read from the console, the way to do it is by saying fgets standard in, and it will return a complete line with a new line character, which you then have to get rid of using trim. Fortunately, there are some easier ways to read files. So file get contents and the file name will open the file, read the entire file into the string, assigning it to contents, and then close the file. If you already, or this one right here, will open the file, read the file as an array of lines, and close the file. If you have a string or an array of lines, then file put contents and a file name and what you want to print will open the file, write the string or the array of lines to the file, and close the file. So these are much handier than having to actually open a command and laboriously read one line at a time. Now, if the file is enormous and can't fit in memory, you have to use this old idiom of opening, calling fgets, and closing the file. But if this file is relatively small, then I strongly urge you to use these commands because they are far simpler. Okay. Then remember I said that there are built-in lists and arrays. So in PHP, it's a built-in array. So you have your normal indexed arrays, which you can create either with an array command by simply assigning to the array as though it is an indexed array. You can append to an array by simply leaving off the index. So this appends Peter to the end of the array. This appends Quagmire to the end of the array. Or since version 5.4 of PHP, you can simply use this square bracket notation to create an indexed array. If you want to create a associative array, that is a dictionary, again, the way to do it is say array, you provide it with name value pairs, and this equal greater than sign separating the key and the value. Okay, and it's easy. So then when you refer to items in an associative array, you use the usual array syntax, but the key is what appears in this bracket notation. Okay, so very simple to create hash tables and assign values. This assigns the value 32 to the key Peter, and this assigns the value 30 to the key Quagmire. Okay, and it's easy to create multi-dimensional arrays. Okay, and as I already indicated, print R is a useful function for printing the elements of an array. And I have some other useful commands here, which I'm running out of time, so I'm not going to cover because I want to get to these sort commands quickly. If you want to sort a numeric indexed array, then sort and rsort will do it for you. They will sort either on numeric or alphabetic values. So this sort type parameter allows you to specify either sort numeric or sort string to indicate that you're sorting either numerically or using a string value. The sort is done in place. So when you're done, the list is modified and it is sorted. If you want to sort an associative array on its values, use asort. If you want to sort it on its keys, use ksort. So this is very handy for just easily, you accumulate a bunch of values using the dictionary. Now you want to sort on the values, like say word frequencies, if you're counting the words in a file and you want to know their word frequency, and then at the end you want to sort by word frequency, a sort would do the trick. If instead you wanted to sort by the word, you would use ksort. Now, that only works, these sort methods only work for numeric and strings. If you want to sort on other values, you have to use these three sort functions, usort, uasort, and uksort, which allows you to provide a comparison function. And your comparison function takes two parameters, a and b. It returns -1, 0, or 1, depending on whether a is less than b, equal to b, or greater than b. So these sort functions are very useful. Last thing for today, your while, for, and do while loops are the same as in C, but you have two additional for loops. If you want to iterate through the values of a indexed array, you can say for each $array as value, and in turn, each value in the array will be assigned to this variable. You can iterate through the key value pairs of an associative array this way. So each key value pair will be, the key will be assigned to whatever is on the left side of the arrow, and the value will be assigned to whatever on the right side of the arrow. Okay, so I know I went through this fairly quickly, but as I said, PHP, if you know C or C++, PHP is almost invariably has the same syntax. So there's just a few new bells and whistles that you need to know for PHP. The important ones being string interpolation, built-in arrays, and hash tables. These convenient for each loops that you are able to use. And the fact that the switch statements can use strings as well as numbers for the cases. Okay, so with that, I'm going to let you go. On Tuesday, we are going to start looking at how you can do form handling with PHP. So how you can interact with the client in order to take input from the client and manage input from the client. So have a good weekend. I will see you Tuesday. I'm also here for questions if you want. Otherwise, feel free to go, and I will see you on Tuesday.
Thank you.